Let's talk about vectors and how we can add force vectors to figure out the resultant force. You probably know that a vector is simply a physical quantity that has both a magnitude and a direction. We can show vectors using arrows like this. So in this example, we're showing the velocity of a car. The length of the arrow represents the magnitude of the vector. So the longer the arrow, the bigger the magnitude, and vice versa. The angle is what gives the direction. So in this example, we see that the arrow is 30 degrees away from the x-axis. In other words, it gives us the direction of the line of action. Now let's move on to forces. Forces are also shown using arrows. For example, here we see two forces applied to this object. When we have multiple forces applied to an object, we can figure out something called the resultant force. All it means is that it's the addition of all the vectors represented by a single arrow. So really, we're taking multiple arrows and showing all of them as one arrow. The resultant force shows us the same effect on the object that the original forces do. We can do this in a few ways, but in this video, we're going to use something called the parallelogram law of addition. In the next few examples, we will go over how to use it. But before we do that, to use the parallelogram law of addition, you should know how to use the sine law and the cosine law, since pretty much all of it is just solving triangles. Without further ado, let's get started with some examples. Let's take a look at this problem. There are two forces applied to the object, and we need to find the magnitude of the resultant force and its direction. We will use the parallelogram law of addition to solve this problem. The first step is to draw a line that is parallel to the 700 Newton force. Next, a line that's parallel to the 450 Newton force. Notice how this creates a parallelogram. You can see where the name for this law comes from. Now if we draw another arrow starting from the origin to where these two lines intersect, that's our resultant force vector. It's the diagonal of the parallelogram. Notice also that we have two triangles formed. You can solve this problem using either of the triangles. I'm going to pick the one on top and move it out. So one side of the triangle is 450 newtons and the other side is 700 newtons. To find the remaining side, we can use the law of cosines. But to use it, we actually need an angle inside the triangle. The easiest one to figure out is actually the top angle. If we draw a line parallel to the x-axis at the top, then the whole angle has to be 60 degrees because it's an alternate interior angle. Now we know that the 700 Newton force is 15 degrees below the x-axis, which means the angle between the x-axis parallel line and the 700 Newton parallel line is 15 degrees at the top as well. So if we subtract one from the other, we get 45 degrees. Now we can apply the law of cosines. Let's solve. Just this value isn't a complete answer. We need an angle to show the direction of the resultant force since it's a vector. So what we need is to find the angle it makes with respect to the x-axis. So first, let's find the bottom angle in our triangle. For that, we can again use the law of cosines. Solving gives us the angle inside the triangle. To get the full angle from the x-axis, all we need to do is add the 60 degrees. So the answer to our question is both of these parts. Let's take a look at this question, where we need to figure out the angle between the two forces so that the resultant force would have a magnitude of 800 newtons. So the first step is to draw the parallel lines, starting with the 400 Newton force. Now for the 600 Newton force. Next, we draw our resultant force to the point of intersection. The goal of this problem is to figure out this theta value. But notice how this theta value plus the top angle must equal 180 degrees since these are consecutive interior angles. In other words, the angle at the top is 180 degrees minus theta. Now let's bring our triangle out. We can figure out the theta value by writing the law of cosines. Let's simplify. If we take the inverse of cosine, then we can solve for theta. So for the resultant force to have a magnitude of 800 newtons, the angle has to be 75 degrees. Let's take a look at one last example. In this question, we need to figure out the magnitude of the resultant force and the angle theta if the resultant force is directed vertically upwards. In other words, we need the resultant force to point up on the y-axis. So the first step is to draw our parallel lines, starting with our 500 Newton force. Next, the 600 Newton force. Now we can draw our resultant force, which is straight upwards. we can easily figure out the top angle since the 30-degree angle is an alternate interior angle. Now we can bring our triangle out. For this example, let's use the law of sines. Let's write it down. Now we can solve for theta. Let's figure out the last angle left inside the triangle. Using this, we can write another law of sines to figure out the resultant force, and that's our answer. That should cover the types of problems you will face when it comes to finding resultant forces and the addition of forces. In the next video, we will cover how to break forces in the x and y plane into x and y components. Thanks for watching and best of luck with your studies.